Alright guys, we're going to look at how to name and write ionic compounds for today, but a quick review on ions. Remember, an ion is any time an atom has an unequal number of protons to electrons. And remember, protons don't ever change, so really what we're looking at is the change in the electrons. We have two types of ions. We have a cation and an anion. Remember, cations are positive, anions are negative. Cations are positive because they lose electrons. Anions are negative because they gain electrons. Remember, with cations, these are our metals, and anions are our nonmetals. Whoops. Nonmetals. Okay. With our naming, let's say we were dealing with sodium. Well, sodium is Na. It has one valence electron. It's going to lose that valence electron, giving it a +1 charge. When we're naming cations, remember, we really just name them based off their elements. So this is just named sodium, our sodium ion. Let's say we were looking at chlorine. Okay, well, chlorine is Cl. It has 7 valence electrons. It's going to gain 1, so it gets a -1 charge, and we change the name of this to chloride. This naming system where we change the anions ending to IDE and leaving the cation name alone is going to play a big role in today, so hopefully we remember how to do that from before Thanksgiving break. Looking at types of bonds, we have two different types of bonds. We are just focusing on ionic for today. We will look at covalent a little bit later this week or next week. Ionic compounds are when two elements transfer electrons. This occurs because we have that cation-anion relationship. Remember, cations are losing electrons. They're not just losing them to space somewhere, they're actually giving those electrons away. And who they're giving them away to is the anion. So the cation literally loses electrons and transfers them to the anion, which makes this guy positive and this guy negative. And this is how we form a bond, and we call that bond an ionic compound. We also have covalent bonds. Again, we'll look at that later. That's just when they share. So if you remember those definitions from your website that we did before the break. Ionic compounds are, again, when you have a cation and anion forming together. It's when they transfer electrons. What we form is a chemical formula. This is when we look at the element symbols, and in the element symbols put together, the cation always comes first, and the anion always comes second. We also have within this chemical formula something called subscripts, which you probably know from math. It's the little number that comes off to the side. This is the number of elements in each compound, meaning, let's say I have Na2O. This 2 is a subscript, and it means there are 2 sodiums. The fact that there is no subscript behind oxygen means that there's only 1. It is not a 0. Just like in math, you don't say 1x, you just say x. We'll do the same thing in here where we just don't show the 1s at all. Now, if I was to give you 3 different versions of sodium chloride, could you pick out the right one? More likely than not, yes. You're going to tell me this is sodium chloride, our table salt. You guys know it's NaCl just from everyday lingo and different things you see and watch on TV. Now the question comes, why is sodium chloride just NaCl? Why is it just 1 sodium and 1 chlorine forming this compound? Well, this actually comes from why ionic compounds form, and it's that transfer of electrons. When these electrons transfer, the compound that forms must be neutral. And remember, neutral means a 0 charge. So let's say we're looking at sodium and oxygen. Well, sodium we know is a +1 just off our periodic table, and oxygen we know is a -2. Well, if I put 1 sodium with 1 oxygen, look at their charges. This would be a +1 and a -2. If I add those two things together, I'm going to get a -1. That's not neutral. So nature will never form a compound where it's not a neutral compound. So instead, what happens is 2 sodiums are going to come together to cancel out 1 oxygen. So now look at this. 2 sodiums gives us a +2, +1 and +1 gives us +2. 1 oxygen is going to give us -2. Now if I put +2 and -2 together, I get 0. That is a neutral compound. So we would write this compound as Na2, meaning we have 2 sodiums, and O1, meaning we only have 1 oxygen. This is where these subscripts come from. Same thing if we were to look at sodium and chlorine. Let me clear this off real quick. If I was to look at sodium and chlorine, sodium's a +1, chlorine is a -1. Notice +1 and -1 automatically equal 0 when they're added together, so we only need 1 sodium and 1 chlorine. That's where sodium chloride actually comes from. Now, there's an easier way to do this. We call it the cross and drop method, or the cross and swap, or swap and drop. There's a couple different ways to do it. But literally what you do is you just write the ion symbol out. So sodium, again, is Na+1. Oxygen is O-2. And we're just going to take these charges, are literally the numeric values, and cross them down and over. And we will drop the positive and negative number. Reason being, on top, they're charges, so they can be positive, negative. When they drop down to the bottom, they're actually numeric values or counting values, meaning they can't be negative anymore. It's how many sodiums or how many oxygens when it's a subscript, which you can't have a negative number of sodiums or oxygens. So in this case, we're bringing the 2 down, so we're going to get Na2, and we bring the 1 down to oxygen, and we get O1. And again, we just don't show the 1. So let's look at another one real quick. Let's say I wanted to put together aluminum and oxygen. Okay, well, aluminum is Al+3. Oxygen is O-2. Now I can go through and do basically which number are they going to cancel out and how are they going to get neutral, which ends up being 6. Or I can just take these numbers and cross them down and make my life a little bit easier. So I end up with Al, and again, all we're bringing down is a 2, not the negative. The negative disappears, and O3. And again, if we were to look at these numbers, they would equal neutral. So if I have 2 aluminums, that's 2 +3s, which gives me a total of +6. If I have 3 oxygens, that's 3 -2s, which gives me a total of -6, and that adds up to be 0. So without doing all this work, we can cross and swap and we get our compound pretty simply. Okay, look at another one, calcium and oxygen. Calcium is Ca+2, oxygen -2. Again, cross and swap, meaning I'm bringing my numbers down. I get Ca2O2. Now, the fun thing about ionic compounds is that they are in simple whole number ratios, meaning this 2 and 2 is not a simplified ratio. They can be simplified. Think of them as fractions if that helps you. So if I have 2 to 2 ratio, I actually have a 1 to 1 ratio. So calcium and oxygen is actually just CaO, 1 calcium to 1 oxygen. Okay? Now for naming, the good thing is because we've already had you naming the ions themselves, the naming's pretty easy. It's the same thing we've been doing. The name of the metal is just the name of the metal directly out the periodic table. So sodium is just sodium. And then the ending of the nonmetal, or the anion, we change to IDE just like we have been. So chlorine becomes chloride. So pretty simple considering, pretty simple considering we've already been doing that. So let's look at one. Na2O. Na is sodium, so we just write sodium. Okay, and then O is oxygen, which becomes oxide. So this is just simply sodium oxide. Okay, look at another one, CaCl2. Okay, and ask yourself, where did that 2 come from? If you can answer that, you're in a good position and so far in this chapter. If you can't, you need to go back and rewatch this video a little bit and figure out where that 2 is coming from in this chemical formula. And also, what does that 2 actually mean? In terms of naming, Ca is calcium, so we have calcium. Whoops, well, it's a U. And then we have Cl, which is chlorine, becomes chloride. So CaCl2 is just calcium chloride. Okay. Now, let's say I gave you the chemical name, and I want you to write the symbols, because we won't always start with the elements. We might actually start with a name already. So strontium, what I would want you to do is write out the symbol with its charge. So strontium is Sr+2. Oxide, remember, is just oxygen with a negative charge, so O-2. So we just pull those directly off the periodic table, remembering that the IDE is just the change in name. And again, to write the compound, I want you to cross and swap. and we get Sr2O2. And again, remember the 2 simplify, so strontium oxide is just SRO. Okay. Let's look at some quick practice and then we'll talk about transition metals. I'm not going to do all of these. Let's look at aluminum sulfide. Okay, well aluminum is Al plus 3, sulfide is S minus 2. Because remember, sulfide is just sulfur with its charge. Cross and swap, aluminum sulfide is Al2S3. Okay, barium fluoride, barium is Ba plus 2, fluoride is F minus 1. Cross and swap, we get BaF2. Okay, let's look down here. Let's see if I want to name these. This is gallium and phosphorus. So I'm not even going to worry about charges because the charges are already simplified if they're in a formula like this. So Ga is just gallium, so we'll write gallium. Phosphorus is phosphide. Let's look at Ca3N2. Ca is calcium. Okay, N is nitrogen, it becomes nitride. So this compound is calcium nitride. Go back through and look at these other 4 that we haven't done. Make sure you're able to do them, just so you have an idea. Sodium nitride is going to be Na3N. Calcium chloride is going to be CaCl2. Li2O is going to be lithium oxide. Okay, and there's a space between that. And then magnesium iodide. Okay, and just so you know, I capitalize my letters. They are not proper names, so they are not supposed to be capitalized, but at least in the names themselves. Obviously, chemical symbols stay capitalized like they have been, but just so you know, in case you see it later as just lowercase c, lowercase n. Okay, we are going to pause real quick because I'm running out of time for this video. I'm going to finish this one up, and we'll come back and look at transition metals in just a second.